Hello everyone. In this video we are going to talk about creating multi-bodies or multi-body parts MBPs in SolidWorks as opposed to creating assemblies. So a multi-body is actually very similar to an assembly. It is basically made of several parts, several rigid objects, but there is no motion associated to those rigid bodies. In other words, they don't move with respect to each other. Okay, so they are held in a specific position and orientation with respect to each other. So it really makes a static system of objects rather than a dynamic one. And the good thing about it is you can do it all in the part design, and you can do it all. You can have all of those different solid bodies under the umbrella of a single file instead of several different files and assembly for them. So let's say, for example, if you want to go with a simple example, let's say you want to make a simple chair. So if you want to make a simple chair, you have the back part, you have the sitting area, and you have the four legs, right? So you have 6 objects in real life, right? You make those 6 objects and then let's say you nail them together, or if they are made of metals, you weld them together. So for these areas that you have solid connection or permanent connection, this, as I said, or static connection, this multi-body is really useful. And you might say, well, I can make that whole thing in a single part without multi-bodies. That's right. So why do I do multi-bodies? I'll show you the advantages. So let's go ahead and do that. So here we go on the top plane, go to sketch, and then draw some, let's say, simple rectangle. Let's say this is the sitting area. And let's say, for example, this is like 15 inches. And then this side here is also, let's say, 12 inches. Right, and you get out. So let me make sure my system is in the inch system. And now you're going to take the sketch and extrude it for, let's say, 1 inch. So let's say this is the area that you sit, right? Now, if I want to make the back area, what I can do is I can come to this plane and then add the rectangle. Again, I'm making it as simple as possible. The goal here is not to do a fancy design, just to show you the basics. So here, let's say I make this guy 2 inches and get out. And now when I go to extrude, this is the part that we need to pay attention. And let's say here I make this, for example, let's say 30 inches or so. Now, too long, maybe too many. Yes. So now pay attention here. Whenever we do any feature, any 3D feature, one of the options that we might not have paid attention to so much is this guy, merge result. If you merge result, it is going to attach this extrude to the previous extrude and make it one single solid object. Okay, if you look right now under the folder, there is a folder under the spec tree called solid bodies. And right now I have only one solid object. Now, if I choose this sketch and extrude it, as I said, then it is going to basically join these 2 extrudes together and should make what? One single solid object, right? So let me give this a little bit of draft just to make it a little bit nicer, something like that. So now if you look, I only have what? I only have one solid object called boss extrude 2, and this is the combination of these 2 together. I only have one solid object, but I could have selected when I did the boss extrude to not merge them together. If I not merge them together, now look, I have 2 separate bodies, and what's good about it, the good thing is I can apply different properties to these different solid objects While if they were just combined into one, then I could have applied those properties to the entire thing and not individually. And you might say, what, like color? No, color I could have done even they were merged them together. I could have applied different colors to these two features. So it's not about color, but one of them is material. If this was one single solid object, when I come here to material, right? I could what? I could, if I say material and apply that, edit material, what's going to happen? If I, let's say, apply, for example, wood to this, what's going to happen? You see, right now, it has applied it to both of them, just like part design. But now, let's say I want this part of it to be made of rubber, the back part of it to be made of wood, or something similar, right? Can I do that? Sure. So to make that actually a little bit nicer, let me do something. So here I make this like 0.5 inches, like this, and now I can add also a layer below this 0.5 inches and say that layer below it is made of wood, but this layer here, it is going to be like the rubber cushion, right? So let me show you here. First, I'm going to basically create that wooden part of the sitting area, maybe something like this. Make it a little bit smaller than that cushion area, so like 11.5, and extrude this downward for maybe 1 inches. Good. So now, again, you see here, since I did not use the option of the not merge, it merged what? It merged these two objects together, right? So if I go back and say, hey, do not merge, then it is going to make it what? 3 separate objects, as you can see. And there is visible edges between them. Although these two surfaces are flush with each other, but because they are separate objects, you see a visible edge here. Now, when I did merge, why didn't it merge that bottom's object with everything else? Because these two objects already were not merged. So all it could do is to merge that wooden part to the closest thing, to the thing that it has connection with. And all it had connection with was what? Was this rubber layer, right? So that's where you can say, hey, the scope of this feature is selected by the auto select, or let me select, let me tell you merge it with what, or so on, correct? So right now, let's say I don't want to merge. I want 3 separate things. And you see they're all made of what? These 3 objects are all made of wood. But now if I want this layer to be made of cushion, I right click here, go to material and say, hey, I want it out of rubber. And now look. Yes? So you see here I could easily what? Could easily get what I wanted. And let me, for just a little bit better graphics, let me put some fillet radius on these 2 areas. Correct? So something like that. Good. So that's one of the main advantages, is you could apply basically different material, right? And now let's go ahead and show you some other things. So let's say I want to create the legs. So I go here to the sketch and create one of the legs here. Let's say I go here and create a leg. Let's say 2 inch by 2 inch. Like this, get out and extrude that, and choose some appropriate length, maybe let's say 15 inches, something like that. This looks good to me. And now let's say this one I want it out of metal. Correct? So now I can go, and you see again, I did not do merge, so it merged now with the bottom wood. But if I want again, I can say, hey, do not merge. This is a separate object. and you do that, and now you see this is a separate object like this. Now if I want to make the rest of the legs, am I going to basically repeat this 4 more times? No, I can definitely use pattern if I want. By the way, let me apply some let's say aluminum, leg out of aluminum, something like that. So now if I want to repeat that, what do I do? So I'm going to pattern this first, right? So I select this object and then go to pattern, right? So let's go ahead and apply a linear pattern to this. And then this is direction 1, and I want only 2 of that. And the distance, remember the whole distance was like 30 inches if I'm not mistaken, right? Or 15 by 12. So let me go back again, and so the distance should be 15, but the width is 2, so it should be like 13. And I bring down this to 2, so that should be 1 of that. And the other thing is for direction 2, I choose this direction, and I should of course reverse it like this, and this one is going to be 12 minus 2, so it should be 10, and then again 2 samples. And then here it says what body do you want to repeat, so I go to bodies and then I select this guy, and now you see I get my all of the legs, right, like this. Good. So these are my legs. Seems like one of them I changed a little bit too much, and I know why, because I left like 1 inch of it off, so this should be 9, or 9.5 really, like this. Good. So you see clearly here with multi-objects, I could apply different material to different part of the same object under part design. It's a multi-part. You see clearly it is made of several solid objects, here 7. And now sometimes you might say, well, maybe I want to rotate some of these legs. All I could do was I could just pattern them. If I want one of these legs to be, let's say, rotated or moved a little bit with respect to the current position it has, can I do it? The answer is sure. All you need to do under the features, I click here on move copy body. You click on this and it says what is it that you want to move. Say, well, maybe these 2 front legs, I want to rotate them a little bit. So you click here, then it allows you to translate it along any direction where XYZ is given, or rotate about any direction as much as you want. So here I want to rotate about the y-axis, and let's say I only want to rotate 10 degrees, right? So if I do that, you see? So now this one is rotated 10 degrees. And if that's not what you want, you can go ahead and basically change it to whatever you want. So you see clearly here, I could rotate this 10 degrees. And if I show it to you from the bottom, you clearly see that now the leg is kind of sticking out a little bit. So now can I move it inside? Absolutely. Again, you can apply the same thing here, right? And if you apply it to this rotated version and you apply some translation to it, let's say I bring it down in the Z direction for, let's say, -0.2, right? Bring it down, and then in the X direction for +0.2, right? Or if it's not enough, you can go 1/2 inch. Then you clearly see now that you could have brought it what? Inward, right? So I can easily basically manipulate each one of these bodies using the move and copy, which allows me to rotate and translate any individual body. So these are similar to the constraints that you had in assembly. And then let's say I can do a similar thing on this one too, right? So for this one, let's say I want +10 degree rotation. and I get something like that. And again, all I need to do is to apply some motion to this one, and this time I need to move negative 0.5 for X and negative 0.5 for Z to bring it inside like this, right? So you see, these two I could easily make them kind of symmetric with respect to each other, and these two I can do the same thing for them. So that's the advantage, that you can use the move copy and basically manipulate the parts, the individual bodies, just like what we did in assembly. Now, if you don't want any part, you can simply delete it, right? So you can say, hey, I want to delete a body. It says what body? You click on this and say, hey, gone. Just as simple as that, right? So that's one thing you can do. And the other thing is the rollback. So here you see I have applied some manipulation to two of the legs, the front legs, right? And the thing is this: if I go ahead and let's say now if I apply a change to one of these rotated, translated legs, is that going to affect the rest of them? So to do that, here I'm going to apply a fillet to this edge, let's say with 1/2 inch radius like this, and I go, and you clearly see that it has not been applied to the rest of them, right? Yes. Now on the other hand, why? Because this one is probably a copy of something else. They all came from this original leg. So you might say, well, if you do the fillet on this one, is that going to affect the rest? So let's go ahead and do that. And you see it's not. Did you see that? I applied the fillet to this edge of this leg, using which I did a pattern and got the 3 others. But that fillet is not applied to the edges, the similar edge on the other legs. So although I did a pattern, but these guys are separate from each other. They are independent. They are not connected really in the software together. So applying something to one is not going to be affecting the other ones that are made using a pattern or a mirror or something, unless you do this. Before I do this fillet, I use my rollback bar and bring it before this pattern. So all of these are gone, right? As if they don't exist. I suppress them. Now I apply a fillet to this edge. Good. Now look, if I bring back the rollback bar to the bottom, you see? So I went back, and before I do my pattern, I did a fillet. So my leg was already filleted. The fillet is applied here, not all the way down at the bottom. And now that the leg is filleted, I patterned it. So now all of my legs have a fillet in them. So keep that in mind, how you can use the rollback bar and apply a change to all of the other bodies you have copied, you have patterned, you have mirrored, and so on and so forth. One other thing about multi-body parts is, if you, let's say, create a cut extrude, right? Is this cut extrude, and this cut extrude passes through several of these body parts, several of these rigid bodies, solid bodies. Could you control which one of them to cut, which one of them not to cut? The answer is yes. So let's say, for example, I go here and I create some pattern to cut. Let's say, for example, I do an elongated hole, and I do one here, right? Something like this. And then let's say I can mirror that with respect to the center and create another one on the other side. So I choose this, mirror that with respect to this edge, and get one on the other side. And now I want to use this sketch and do a cut extrude. Now, look, when I do a cut extrude with as much height as I said, even if it's 2 inches, still passes through both the wooden part of the sitting area and the cushion, the rubber cushion. What if I don't want this to affect the cushion? Then I come here and it says feature scope, right? Do you want it to affect selected bodies, all bodies, or do you want it to auto select? Say no. I'll tell you what's to be affected. You don't auto select for me. I'll tell you the selected bodies to only be cut. And it says, okay, fine. Which one? And it says only the wooden part. I do not want you to cut through the rubber, right? And look now. You see? The wooden part is cut, not the rubber. But if I went here and say, well, also for me, cut the rubber too. So here I come, and at the bottom of this, I also say, okay, how about you add the rubber too? Now look. You see? Now you're cutting through both of them. So you can select the scope, which means the parts, the body parts, the solid parts that are not parts, solid bodies that are going to be affected. Good. And you see this cut extrude is now considered a solid object. So instead of the rubber being a solid body, now the rubber with the cut extrude, it is called a solid body. And then this one too, right? For the wooden part. And if the names are kind of meaningless, go ahead and rename them, right? So instead of calling it, for example, some irrelevant name like what? Solid extrude 2 or something. Let's see if we can use, yes, I used F2. And now instead of that, I call it like the back. And here I went and used F2 again and renamed all of the other items. So now basically I have more relevant name, and now this is really a multi-body part. And when the manipulation of these parts using that move copy is done and the parts are in the position that they're supposed to be, now you can, if you want, you can merge them into one object. So the way to go about it is you click on combine, and it says, okay, do you want to add objects? Do you want to subtract objects, or common? Common means intersection. And this is basically a Boolean operation. Do you want to apply a Boolean operation? And I say yes. What bodies? And then here you go to this folder, and then you select all of the objects, and then you say add them all together. And it does, and now look what happens. All of those 7 objects are now collapsed into one object, which is called combine 1, and that is your entire chair. Yes? So if you want, you can always combine them into one object, although you don't have to. But remember, at the end of the day, the connection in multi-body is solid connection. Okay, so here I moved the holes a little bit further in to be able to add some handles. And you might say, well, if I want to, let's say, add 2 handles now, should we again go ahead and make those handles here in part design and just not merge them to the rest? Or let's say if we have some handle part from some other software or some other like website we downloaded or anything, can we join it here without us having to redo everything from scratch? And the answer is yes. If it's a part, you can go ahead and insert that part here, and you see not only you can add SolidWorks parts, you can add Autodesk Inverter, CATIA, you can add IGES, you can add Creo and some other CAD software, right? You can add them all directly the part, or if it's, let's say, a mesh file like STL or something, and also add that through imported geometry. So you go there, and then you can add Parasolid, Rhino, 3MF, STL, and so on, right? So let's say I want to bring an STL file, and I use this handle, right? Let's say I got this from somebody else, although really I got it from a previous design of mine. So let's say I want to add this here. So what I need to do is to first position it properly where it belongs. Let's say I want to put it right on the top of this rubber here, right? So how do I know how much I should translate it to fit this bottom surface of it right here? So for that, all I need to do is to do measurements. So if I go here and just click here, that gives me an area. But if I click on a specific point on that surface, like this point, that gives me X, Y, and Z. So if you see Z, right, or Y in this actually, Y, which is the height, is 0.5. Now, if I repeat that for a point here, the Y of that point is 0. So it's 0 versus what? Versus 0.5. So it clearly shows that the bottom of the handle has to be lifted for half an inch to come and basically be flush with the cushion area. So all I need is this imported object, which is now added here also under my solid folder. All I need is to go and use this move, correct, copy object. Then I choose this and it says how much do you want to move it, and I say along Y I want to lift it up for half an inch. And it does, and now if you look from the side view, you clearly see that they are flush now. Okay, going back to 3D view, now I can move this to the desired location along on the cushion, right? So I can just go ahead and click on the move copy again, choose this guy, and this time instead of typing a number, I can just literally use the arrows and put it to where I want, as long as it's not like super critical to me the exact location of it to be in terms of numbers, just something visually correct like this, right? And then move it back like that, correct? Then I can say, well, that's good enough for me. So here I just kind of look that there is some gap still here, and I okay that. So now let's say the handle is in good shape, and now if I want another one over there, all I need is to mirror that. So I choose this object here. Now I'll go to mirror and I'll try to what? I'll try to mirror that. And here it is asking for a plane, right? And let's see if I can use the mid plane here. This one, there we go. And you get the mirror one as well. So now let's say this is your multi body object. Again, you can choose to change it to anything you want. So let's say here I use a plastic like ABS, PC ABS, and I have applied it to both of them because one of them is the mirror of the other one. So now let's say this is your final multi-body part, and I already saved it as chair as a SolidWorks multi-body part. But now let's say you want to convert it into STL and go and print it. So here when I go to File, Save As, then save it as STL. Here under Options you have the option of what? Saving all components of an assembly, or in this case multi-body part, into a single file, and that's what I want to do. So I say fine, yes, that's what I want, and I call it chair.stl. So I save it, and now when I go here and I try to bring it, of course it's going to be huge. So let me go ahead and scale it down. So let's say scale factor of probably even 10% was good, maybe so 20% or even 30%. Yeah, it's out of the area, so 20%. Okay, so let's say this is the chair that you made. Now if you remember, in one of our previous video we talked about printing a separate part of it out of separate colors or separate material. using the multi-material upgrade unit that Prusa has. So here, if you slice it, it is going to be all one piece. But let's say you have different spools in that multi-material head and you want to tell it, hey, for example, print the back out of one color, print the cushion out of one color, the legs one color, the handle something, right? You want to really break this into individual parts. So if you remember from that video that my technician taught you, he mentioned that you can take this STL into an intermediate software like Autodesk Fusion or Blender, and in there you break it down into individual components without really moving any component of it out of position, just where they are. You tell it, hey, this whole chair, don't consider it as a single part, consider it as individual components, although they are all connected together in static positions, but basically use different properties for printing them. So if you want also here in Prusa, remember you have breaking it into objects or breaking it into parts. So here in the past I showed you breaking it into object like an assembly. So if instead you break it into parts, look, now it has broken it into 9 components, and guess what? Each one of these components is exactly one of those solid objects that we had in SolidWorks, right? Clearly it could easily recognize it because we created the part in SolidWorks in the beginning as a multi-body part. So now it's very easy for Prusa to break them down into 9 pieces without changing their position or anything. So this is very good. And now if you have the multi-material upgrade, you can go to the setting for each and then change the color of the spool or anything. Here I don't have that upgrade. So if I want, for example, I can change the number of layers for each one of these. So let's say I want the back to be printed with 5 shells in all directions, right? I want the sitting area, which is let's say this one here. I want this one to be printed with maybe 8 shells, right? And then maybe, for example, the rest of it to be the standard, that is like 4 to 5, bottom 4, right, top 5, and then perimeter 2. So look, if I go ahead and slice it right now, then the number of layers for the back part and for the sitting area should be different than the rest, because I have 9 separate parts and I could customize each one. And now you can easily see, if I go to my sitting area, the back area, you clearly see there are 4 shells, right? Then if I go further down and I get to the cushion, you clearly see in the cushion I have what? I clearly have 2 shells. If you remember, the perimeter was 2 shells. But if I go further down to what? To the wooden area, look what happens now when you go down. Boom. So now you have what? You have 8 shells, because that's what you set up for the sitting area. And if you go down to the legs again, you go back to 2 shells on the perimeter, right? Now, again, if it was different colors, if you have different spools, you had the software updated for multi-material, then not only you could change the number of layers or infills of each component, each part separately, you could also tell the software that to print each one of them out of a separate spool, out of a separate color. And then you get your multi-color parts, really. So that's the advantage of using a multi-part in SolidWorks and saving the STL, because when you bring it here, you can simply break it into parts, split it into parts, and you do not need the Fusion, right, 360, or you do not need Blender or anything. just by proper design in SolidWorks and by simply breaking into parts, you are good to go for a multi-color part. So hopefully this brief intro to SolidWorks multi-body parts, MBP, is useful to you. Again, in here, the connection is static. The parts are not going to move with respect to each other, whether we combine them or not. It's not like assembly where you apply joints, you apply constraints, and the parts can move with respect to each other if you want. The positioning here is not as accurate as assembly. And if you want to do that, you have to do a bunch of measurements. So if you really care about checking interference and tolerances and everything, you better use assembly instead of here. But the big advantage of this is you have all of these different solid objects under one SolidWorks part instead of having them under 9 different parts. Okay, so it is going to make your creation of the static part faster, and it is going to use a lot less memory. So hopefully this one was useful to you, and I will see you in my next video. Thank you.